Hello everyone, my name is Mr. Hassan. Today's lesson is about properties of real numbers. Now we're going to start by classifying numbers. As you can see, there are a set of numbers that represents the real numbers, or let's say subset of the real number. The smallest set is called the natural numbers, and the symbol is n, as you can see from here. They are 1, 2, 3, 4, 5, and etc. They never end. 0 is not part of it. Actually, 0 is part of the whole numbers, as you can see. That's why n is a subset of w. So natural numbers are a subset of whole numbers. Now, integers contains the whole numbers and their opposite. It's like 5 and negative 5, 17 and negative 17. It also contains 0. Now, the bigger set than the natural numbers, the whole numbers, and the integers is the rational numbers. Rational numbers are numbers that can be written as a over b, where a and b are integers, and b should be different from 0. Of course, you cannot divide by 0. Now, the rational numbers is also part of the real numbers, so it's a subset of it. If the number is not rational, it means we cannot write it as a over b. Of course, it's an irrational number, as in pi, radical 3, radical 7, which means the radical of any number that is not a perfect square. Perfect squares are like 4, 9, 16, etc. You know the rest. Now, important note, any terminated decimal like 0.9 or 2.67 are rational numbers. Even the repeated decimals like 0.1 bar, 2.06 repeated, and other examples, those are rational because you can write them in a specific way as a over b. Now, if the decimal never ends or never repeats, as in pi, as we said, then it's considered as an irrational number. Now, important note, if you find the number in one of these sets, it means it includes for the upper set and not for the smaller sets. So if it's a whole number, it's an integer, rational, and a real number. But this number you found as a whole number is not a natural number, and so on. So let's take a quick example. As you can see, we have to classify radical 6. Now, radical, we look under the radical, which is 6. It's not a perfect square, so directly we say it's an irrational number, and of course you go to the upper set, which is real numbers. What about 5? Now, we know 5, it's a natural number, as we said before. So it's not only a natural number, it's also a whole number, an integer, a rational number, and a real number. Negative 2 over 3. Now, 2 over 3, it looks like rational, but the question first, can I divide 2 by 3? If the answer is no, then of course it's not an integer, whole number, or a natural number. It's directly only a rational number. And not only a rational number, it's also a real number. The second part of this lesson is to name properties of real numbers. Now, addition and multiplication, they have some kind of properties, common properties such as commutative, where a plus b equals b plus a, as you can say, like 2 plus 3 equals 3 plus 2, or as in multiplication, 2 times 3 is 3 times 2. We have associative property. If both of the operations are addition, then it doesn't matter which one you add first, the first two or the last two. So we can move the parentheses as we want because the answer won't change. It doesn't work if you have more than one kind of operation, and it only works for addition and multiplication. Identity property. Identity property, or the identity of addition, is 0. It means if I add any number to 0, it won't change its identity. It's going to say a. Even for multiplication, so the identity for multiplication is 1. Any number multiplied by 1 won't change its identity, so 1 won't change the identity of that number. It's gonna stay a. Now, the inverse. The inverse for a is negative a, or the inverse of negative a is a. Of course, when you add them, you get the identity for the addition, which is 0. It goes the same for multiplication. So a into 1 over a, which is the reciprocal of a, you get 1, the identity of multiplication. So a and 1 over a is 1. We call 1 over a as the multiplication version for a. Now, you should make sure a is different from 0 because, of course, we cannot divide by 0. So the closure. Here, as you can see, that a and b are real numbers, so their sum or their product is still a real number. If you go to distributive property, now distributive property is important. We're going to use it later in this lesson for simplification. So a into b plus c, we're going to do distributive property. We're going to distribute multiplication over addition, so it's going to be a into b plus a into c. It works also from the right side. Now this is a quick example. Now some students, when they say directly the parentheses, they directly think it's the associative property, but they have to make sure what do they have. So from the first side, negative 8 plus 8 became 0. So in this case, the additive property is applied. So this says that the number plus its opposite, it's 0. So it's the additive inverse property. The third thing I'm going to explain today is to identify the additive and the multiplicative inverse of a real number. This is easy actually, because the additive inverse, let's see some small example. They gave us negative 7. They need the additive inverse and the multiplicative inverse. Now the additive inverse is the number you add to negative 7 to get 0. Of course it's the opposite of negative 7, so the additive inverse of negative 7 is 7. Now for the multiplicative inverse, what's the number multiplied by negative 7 to get 1? To get the identity again, identity of multiplication. It's the reciprocal of negative 7. The reciprocal is when you switch the numerator and the denominator. So negative 7, the inverse for negative 7, the multiplicative inverse is negative 1 over 7, because their product is 1. The fourth thing I'm going to display is applying distributive property in real-world examples. Let's see this example. Audrey went to a post office and bought 8 42-cent stamps and 8 27-cent postcard stamps. What was the total amount of money Audrey spent on stamps? Well, there are two ways to find the total amount spent on stamps. You may multiply first, then add, meaning we can multiply the price of each type by its price. So if I have 8 from the first stamp, which costs 42, so it's 8 times 42, plus, because I have and, 8 times 27. So I'll get 3.36 plus 2.16, as in total 5.52. Now we can add, then multiply for the second method. So in this case, we can add the prices of both types of stamps and then multiply the total of 8. So you add their prices and you multiply by 8, which simply is the same answer. So Audrey spends a total of $5.52 on stamps. The last thing I'm going to explain now is to how to simplify expressions by combining like terms and using distributive properties. This is an example. They want us to distribute those. So 4 into 3a minus b plus 2 into b plus 3a. First of all, we're going to use distributive property because we cannot combine like terms inside. Then we're going to multiply 4 into 3a, it's 12a, negative 4 times b is negative 4b, 2 times b is 2b, 2 times 3a, it's 6a. And we can do commutative property, so we're going to put a next to a and b next to b. After that, we can combine like terms or add, like 12a plus 6a, it's 18a, and negative 4b plus 2b, that's negative 2b. Thank you for watching. See you soon.